Okay, here is the fourth 6 weeks test review, and we've already done this in class, but I promised I would do a video just in case someone needed to see it again, or maybe somebody was absent today and they didn't get a chance to see the review. This is your chance to see it on video. Okay, so first of all, let's look at the first question. We're asked to match the sine, cosine, or tangent with its graph. Okay, so if you remember that cosine always starts at 1. So this graph here starts at 1 on, okay, here it is. It starts at 1 on the y-axis. So this curve right here, this is cosine. So cosine starts at 1. So we're going to say that cosine is A. And then over here, if we look at this graph, we see that this graph starts at the origin. Well, we know that's sine because sine starts at the origin. So sine starts at 0. So I guess graph B would be sine then. And then, of course, the last graph we have over here is tangent. And tangent is not a wave, okay? So tangent is a curve. It has some asymptotes here that are not graphed on this particular graph, but I am going to require you to graph in the asymptotes on the graph that you have to do. Okay, so this one is tangent, C. Okay, so let's move on to the graph. Okay, so if you look at the graph, I'm going to make this a little bit bigger. Okie doke. Now this equation is a tangent, and the one on your test will be a tangent as well. If you'll notice that on this tangent equation, we don't have any phase shift. So there's no phase shift here. If you look right here, you'll see that there's nothing happening after the x. So there's no horizontal shift left or right on this graph. So because of that, there's no phase shift. So over here, we're going to put none. And then we're going to start filling in our table for our function. So the insider is what changes the angle. So we have here 1/2 x. Oops. Erase that. Okay, so here we have 1/2 x. This 1/2 right here means that we are going to cut our wave in half, what actually ends up happening is this actually ends up doubling. So we have to multiply by the reciprocal. So what we're going to do over here on the table is we're going to multiply by 2. Okay, so when we multiply by 2, when we're going to multiply all of these angles by 2, we get negative pi over 2, 0, pi over 2, and pi. So this is going to be our new angle. So one of the questions we have to fill in over here on the left is the period. So you can tell now what the period is for the new graph by counting how long it takes to get from one end to the other. So if we know that the period for tangent is pi, and we had to multiply that times 2, well, then we know that our new period is going to be 2 pi. And also, if you look at the table, you can see that to go from negative pi to 0 is 1 pi, and then to go from 0 to a pi is another pi, so that's 2 pi. So we know that our period is 2 pi. So it takes us 2 pi to complete one tangent curve. Okay, so for tangent, the amplitude is infinite because on tangent we go from negative infinity to positive infinity. So tangent kind of looks like that, from negative infinity to positive infinity. So we say that the amplitude is infinite. So I'm just going to abbreviate INF for that. B is our horizontal stretch or compression. In this case, we have a stretch, but it's right here in our equation. B is 1/2. And the vertical slide, of course, is D in our equation, which is that +1 on the end. That's going to shift the graph up 1. So you can say +1 or you can say 1. I would prefer if you put the sign in there so that I know that you know that it's +1 and not -1, and vice versa. Okay, so now we're going to see what changes happen to the function itself. So over here, we've given you the values for the parent function for tangent, and what you need to do is you need to apply these transformations, this A transformation and this D transformation. Those are the transformations that affect the parent function. So 3 is multiplied and 1 is added. So we're always going to multiply before we add. So I'm going to multiply by 3, and I'm going to add 1. I'm going to do that to each one of the values for my tangent function. So first of all, you'll notice that there's an undefined value at -pi and an undefined value at pi. So right here we have two asymptotes. So you can't do anything to the asymptotes. So across your table, you're just going to keep writing undefined, because you can't do anything to that. That's an asymptote. So we are going to change, however, those 3 points in the middle. Those are our critical points. So what we're going to do is, on the first point here, -1, right here, we are going to multiply that times 3. So -1 times 3 is 3. I'm sorry, -3. 0 times 3 is 0. 1 times 3 is 3. Okay, so we're done with that part. Now we need to add 1 to those. So -3 plus 1 is -2. 0 plus 1 is 1. And 3 plus 1 is 4. Now we're ready to graph. Now you'll notice that on your graph you don't have any values for your radian measures, so you can go ahead and put those in. I'm going to make the graph a little bit bigger just so it's a little bit easier for me to write this in. It's really kind of difficult on this small screen, so I'm going to go ahead and make it bigger. Okay, so now when I write this in, you'll be able to see it better too. Okay, at the origin, I'm going to put my 0, because that's still going to be 0. And then if you'll remember looking at the table, if you want to look back at the table, we had -pi, -pi over 2, pi over 2, and pi. Those were our values for our radians, and we're just going to leave it at that. We don't need to add any more radians to the graph, just those radians. Okay, so then we're going to go ahead and put in our function values. I'm going to do it in a different color. At -pi and at pi, we had an asymptote. You have to draw in the asymptotes on your graph. Please don't forget to do that. Okay, I'm going to make it nice and dark so you can see it better. Okay, here it is. Please don't forget to draw in your asymptotes. Those are 2 points each. 2 points for each asymptote, so please draw them in. Then we're going to put in our points. Okay, so at -pi over 2, we had a -2 point right there. Okay, then at 0, we were at 1. That was our vertical shift up 1 unit. And then at pi over 2, we're at 4. Now this doesn't really look like much of a tangent curve. It looks more like a diagonal. But if you go ahead and put a curve sort of in there, you can kind of see that it is a curve. It's just very, very stretched. Because remember, we had a vertical stretch of 3 and a horizontal stretch of 2. So that stretched that tangent graph out quite a bit. All right, so that's why it looks more like a diagonal than it does like a tangent line, but that's what it is. So what am I going to grade? I'm going to grade these asymptotes and these critical points. So make sure you get those on your graph. Okay, so moving on to page 2 of our review. We have a question that says, verify the following trigonometric identities. So remember what I told you to do. We're going to change everything into terms of sine and cosine. So we have a sine x, cosine x, and now we have a cotangent x, and we're going to change that cotangent into cosine over sine. You can find these identities on your math chart. So if you're not sure what they are, you haven't worked with them enough, make sure you check that when you're doing your test. Then we have plus sine squared x plus 1. And we want that to equal 2 when we're finished. Well, if you notice right here where we have sine x cosine x times cosine x over sine x, there's something we can do right here. We can cancel out this sine and this sine. Since these things are all multiplied together, we're allowed to cancel out the signs. So we're going to do that. Cancel, cancel. Say what? So let's see what we have left. We have cosine times cosine is cosine squared x plus sine squared x. Oops, I forgot my x over here. Got to have an x with that sign. Sine squared x plus 1. Okay, so if you remember from your identities, this right here is a Pythagorean identity. Cosine squared x plus sine squared x is 1. And 1 plus 1 is 2. And that's it. We've proved that the left side of the equation is equal to the right side. All right, next problem. Solve the following trigonometric equations. Here you're just solving for x, or theta in this case, the angle measurement. And you're going to solve this just like you solve any algebraic expression. You can actually look at this as an x squared if you want to, and rewrite it as x squared until you're done with the problem. All we're going to do is add 3 to both sides. So that gives me 4 cosine squared x equals 2. Divide both sides by 4. And we've got cosine squared x equals 1/2. And now just like with x squared, if we want to find x, we have to take the square root. So we're going to take the square root. And if you remember from working these problems in class, we calculated the square root of 1/2 to be root 2 over 2. If you're not sure how that happens, come and see me in tutorials. So cosine of x is root 2 over 2, and now what I want to do is I want to look at my my math chart, or my unit circle, to see where cosine is root 2 over 2, and that happens right here. Okay, my cosine value is root 2 over 2. And that happens at when x is pi over 4. And that's your answer. Okay, the next one, sine x, negative 2 sine x plus 5 equals 6. Let me go ahead and move that up a little bit. Okay, so now we have to subtract 5 from both sides. And that leaves us a negative 2 sine x equals 1. Divide by negative 2. Oops. That gives us sine, oops, that's supposed to say sine. Sine x equals negative 1/2. And now I look at my unit circle to see where that happens. And that happens right here. Okay? And that is 11 pi over 6. That's where that happens. All right, next one. Number 8. Here we're solving for an angle. We're solving for this angle right here. And we have the side adjacent to the angle, and we have the hypotenuse. So we have an A and an H, so we're going to use cosine. So cosine of theta equals 5 over 13. Now to find theta, we have to use the inverse. So cosine inverse. Now remember, when we're using the inverse, we flip the side, the ratio side with the angle. So we're going to put the 5/13 on this side of the equal sign, and we're going to put the theta on the other side, okay? Now we're solving for cosine of -1, which is cosine inverse, or arc cosine, and the sides are 5/13, and then we're going to get 1.17 radians. Make sure you put that in radians. That is not degrees. If you want to convert it to degrees, then you need to do a degree conversion, which, if you remember from before Christmas, that's 180 over pi. So you would have to multiply the 1.17 times 180 over pi. Since I'm not requiring you to do that, all you have to do is put the word radians after your answer and put a box around it, and you're done. Next question. Okay, with number 9, we are looking for a side this time. Oops. We are looking for this side right here. We have, according to the angle, this is the side opposite, this is the side adjacent or adjacent, depends on how you want to pronounce that, okay? And so since we have an O and an A, we're going to use a tangent. 16 degrees equals 5 over x. Now remember, if x is in the denominator, we need to divide. So we're going to divide 5 by tangent 16 degrees. Now when you put this in your calculator, real important to remember that you need to put this degree symbol in, because remember, our calculators at school are in radians. And so if you don't put this degree in when you pop this into your calculator, you're going to get the wrong answer. So the answer we got when we did this one in class was 17.4 units. I don't know what the units are, but that's what we got, 17.4 units. Now, if we didn't get that in class when we went through this review, it's probably because we didn't put in this degree symbol when we put this in our calculator. Make sure that you do that. Very important. Okay, next problem, number 10. An airplane rises vertically over a horizontal distance of 7,258 feet. If the angle of elevation of the plane is 25 degrees, how high is the plane? Okay, so we have a side adjacent here, or adjacent, a side opposite. Again, we're going to use tangent, and we have 25 degrees, and x is our side opposite. 7258 is our side adjacent, and now all you have to do is multiply. Since we have x divided by 7258, instead of dividing now, you're going to multiply. Okay, so tangent 25 degrees times 7,258 gives us 3,384 feet. And I'm really not worried about the decimals on this one, so you can just leave it as whole numbers. That's fine, okay? All right, so for number 11, number 11 is all up to you. You have to write 3 sentences to describe how you solved this airplane problem. Okay, number 10. So you have to tell me in at least 3 sentences how you did that. Describe what you did, okay? This is in your own words. So make sure you use complete sentences, and make sure you describe what you did completely. All right, the last one is the bonus question, and we're going to try to, I'm going to go ahead and solve this bonus question for you, but when you take the test, you're going to have to do your own work. So make sure that the one that you do on the test, make sure you check your work very closely and that you haven't made any mistakes. Okay, so for the bonus question so far, what I've done is I've converted everything into terms of sine and cosine. And what I ended up with is cosine squared x over sine x plus cosine over sine minus cosine over sine minus 1 over sine x. And now what we need to do is simplify this a little bit. I'm going to eliminate these two because they cancel each other out. And then what we're left with is cosine squared x minus 1 over sine x equals sine x. Well, let's see what happens here. Cosine squared x minus 1, is that one of our identities? The identity says that sine squared x plus cosine squared x equals 1. Okay, well, if I want sine squared x and I'm going to use this identity, then I need to subtract cosine squared x. So I get sine squared x equals 1 minus cosine squared x. But that's not what our equation says. Our equation says cosine squared x minus 1, which is not the same thing. So what we ended up with here is something that is not a true statement, okay? Because what we would need to do in order to change this cosine squared x minus 1 into a true identity, we would have to multiply everything by a negative 1, which means that this sine x over here needs to be negative, and it's not, it's positive. So this problem is not going to be true unless we change this sign to a negative. And since we can't do that, then this whole equation is not true. It's not going to be true. Okay, so say, for example, we started out and it was negative. Say this was a negative sine x. Okay, well then this identity would work, because now we have, here we would have to multiply by negative, okay? That would be a negative. And we would get negative cosine x plus 1, which is the identity, okay? So in this case, then we would be able to solve this problem. So we would end up with negative sine squared x equals over sine x equals a negative sine x. In this case, it would be true. But if we leave it the way it is, it's not true. Hopefully the one on your test isn't going to be tricky like that, and it will be a little more straightforward. But it is a bonus question, so good luck.